Okay, the first one in the electronic tech one, we already learned about anything regarding to analog signal. Like you learn about diode, transistor, okay, amplifier, even they can amplify or bipolar transistor. On the tech two, different. Okay, basically we can learn more. The real thing happen. If you're looking into the display in general, you say when you talk to your phone, this signal will be your voice. So they have to convert it into the voltage. And when they're coming out, they have to convert it back. Okay? The voice go to speaker. For now, you can see like signal from CD coming out. They will be a binary number. 1011, whatever. That's what they call it. Digital data. So when they go through the system, they have to get the device they call it digital to analog converter. Okay? That means they converting into your voice here, analog. Then, before they go into amplifier, they go to another device, okay? Linear amplifier, okay? Analog reproduction of music audio signal, okay? Then they can be converted to the analog signal, go to the amplifier. So the first thing, they get digital to analog converter. And they have to go into the another device we can call analog, okay, to digital converter, okay? Then they go to the amplifier. Now, in the binary, you understand in your phone, they get a microcontroller, okay? In your computer, microprocessor, they only do one thing. However, now everything will be combined into the system. The IC will be microcontroller. Okay, you see what happened. So, in the computer, only thing computer can know just a binary number, 1 or 0, nothing else. Okay, so the first thing we go to the number system. Number system and the code. Okay, first thing we're talking about decimal number. Decimal number that's using for human. Okay, we're using a decimal number. but the computer don't know anything about decimal number. Okay, so the decimal number, they get a 10 digit. You already know. Number 0, 1, 2, 3, up to 9. Okay, they call a base 10. The thing is they get a 10 digit. Base 10. Okay, the next number system they call a binary number system. That is using for the computer. They only get a 2 digit, either 0 or 1. So the base will be base 2. Okay. The next one, octal number system. 8 digit going from 0, 1, 2, 3, 4, 5, 6, 7. The last one, hexadecimal number system. They get a 16 digit. And you can see they start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then they will be A, B, C, D, E, F. Total will be 16 digits. That's why they call it B60. Okay? So basically we're using decimal number, using the binary number, and the hexadecimal number. Octal number, that's too old. Now computers are not using octal number. Okay? And then, first thing, binary to decimal conversion. The thing is you using the decimal. However, the computer using only binary. So they have to convert it from binary to the decimal. And now try to see how they convert it. If you're looking at the example here, you get a binary 11011. How many bits? Five bits, correct?
Yes, correct.
Now, first thing, they using 2, that's a base 2, to the power. Now, if you stay right here, you count how many bits left. 1, 2, 3, 4. So that's 2 power 4. And they adding to a next one. 1. Okay. 2 power of 3. And they adding to 0, doesn't matter, who cares? So that's why. They adding to next one here. 2 power of 1. And the last one 2 power of 0. Okay. After calculation, they adding up, they get 27. However, base 10. Okay. That means decimal. Okay. To convert binary to decimal, you have to follow this way. Okay. If you get a question, just let me know. 2 power 4, that means 2 times 2 times 2 times 2. 4 times, right? and then the decimal to binary conversion. Okay, if you get the number 25 by 10, that means they in decimal. And now they converting into the binary. Okay, now see how they do it. That's just for the knowledge. We're not doing anything with this thing, okay? First thing, 25 you divide by 2. Then you get 12 and remaining is 1. Okay? Take 25 divide by 2. You get number 12. The remaining 1. Okay? Then they take 12. They divide by 2 again. They get 6. Remaining will be 0. And they take 6 divided by 2 to 2. You get 3. Remaining 0. 3 divided to 2. Keep divide. Okay. You get 1. Remaining 1. 1 divided to 2. You get 0. Remaining 1. So 25 base 10 equivalent. Okay. To go up. Okay. That means here you're going up 1, 1, 0, 0, 1. This is the answer. Okay? That's how to converting from decimal to binary. Okay? Like you typing in your keyboard of the computer. You typing 25. Computer cannot understand 25. Computer only understand binary. So that's why they get a circuitry to converting 25 by 10 to 1, 1, 0, 0, 1. Okay? And now, next one, hexadecimal to decimal conversion. You get the number 3, 5, 6. You know, okay, 3, 5, 6, that's decimal. Human music. But now, that's a base 16. Okay? You want to know what the decimal equivalent 356 in the hex to decimal. What they do? They take number 3 times 16. You understand why 16? Take a hexadecimal. Base 16. Power. 2 number left over. Power 2. Then they adding to number 5 times, okay, 16 base 1, okay, a power 1. And they adding to number 6 times 16, okay, power 0. And you get this number. And this number is decimal. And the 356, that number is hexadecimal. And now, hex to binary If you get a number 9F to 16, that means you get that number in hexadecimal. If you want to convert it in the binary, first thing, you convert it number 9, that is number 9. Number F, that is number F. And number 2, that number 2. Very simple. Okay? You will be see how they will be 1001 or 1111. Okay? In next step. Now, binary to height. If you get a binary here, they want to see what the hexadecimal equivalent. Okay? The way to do from the right to the left. First thing, you select 4 digits, 1, 2, 3, 4. Here. Next, 1, 2, 3, 4. And now you convert it. Okay? 1011. B. 1010A. 110. 6. That's very simple. Okay? On the next page, you can see they given you the table. Okay? Equivalent. Octone to binary, we don't want to telling you. They're not using anymore. Now, another BCD code, binary code decimal. When a number, letter, or words are represented by special group of symbol, this equal encoding. If each digit of decimal number is represented by its binary equivalent, this is produce a code we call a BCD, binary code decimal. 4 bit is required to code for each digit. If you get 874 by 10, that means decimal. And they will be equal. Number 8 in binary will be 1000. Number 7, 0111. And number 4, 0100. You will be see very soon how come we get that number. Okay? And except 3 code perform the same as BCD, except that 3 is added to each decimal digit before encoding in each binary. We don't care about that. We're not using. Alphanumeric code ASC, II, American Standard Code for Information Interchange. That means in your computer, they have to get ASCII. Okay? So they can convert it, okay, from the decimal to the binary, whatever. Here. Now, we see that in electronic, binary represented, okay, by the voltage or current. Okay. TTL, transistor logic, V high, maximum 5.5 volt. V high, minimum 2 volt. That's only telling you any voltage higher than 2 volt and less than 5.5, they will be logic 1. V low, maximum 0.8 volt, minimum 0.0 volt. That means if you get 0.4 volt, they will be logic 0. Okay, this is the table. Okay, for high, binary 1. For low, binary 0. That means minimum high to maximum high will be binary 1. Minimum low to maximum low, they will be binary 0. The thing is, in the digital circuitry, only you deal with logic 1 or logic 0. So, also they controlling you here. This signal they call a clock. That means first 0, they go 1, they go 0, 1, keep going forever. That is a clock signal. Okay? And bit sequence represented by waveform A. That means you can get this is high 1, this is low logic 0, 1, 1. And this will be 0, 0. Okay? Positive going forward. See how they look like. That means the signal, they will be low. Then they go up to high. Then they go down to low again. That's what they call positive going forces. Okay? And another one, opposite. Normally high. When they going low, go high again. That they call a negative going forces. Okay? A portion of a periodic digital waveform is shown. Okay? In this display here. The measurement at in milliseconds determine the following. Okay, you see the signal 0, they going up. Okay, for TW, T weight. Okay, then they going down. And then they could keep going here and try to repeat it again. Now try to see definition. From the beginning here up to the beginning again, they call a period T. Okay, T is a period. And if you want to calculate the duty cycle, then they will be equal to TW. That's right here. TW divide to big T times 100%. Okay, that is a duty cycle. Okay, another thing. Sending device. Okay, in serial. This is a serial. You need only one wire. And this is a binary signal. 1, 0, 1, 1, 0, 1, 1. Okay. So basically, you transmitted a lot of binary, but you're using only one wire. That's what they call serial. Serial data. Okay. Now another device. Same thing. They get the device sending the signal. However, you can see this at 1 bit. Okay, 1 here, 2, 3, 4, 5, 6, 7, 8. If they transmit it in a parallel, okay, so this is a parallel data transfer. The one we just get it done, serial data. So parallel data, you transmit 8 bit, you need 8 wire. 1 wire for 1 bit. However, transmit for serial data, you need only 1 wire. You can transmit 8 bit, 1000 bit, okay? We don't need any more wire. So try to see the practical. Where you know they're using serial data.
A serial cable, like the old school serial cables going to the computer, and the parallels like an old school printer cable.
Okay, now serial data using in your telephone. The thing on your telephone, you talk too much. That means the serial data too many bits. If you're using parallel, you don't have a room to put enough wire. The thing in parallel, 1 bit needs 1 wire. Okay? So that means in the telephone system, they have to be transmitted by serial data. They need only 1 wire. They can transmit it too many binary bits.
So an RJ11 is only one wire?
1 wire for telephone. Binary in parallel, that happen in the computer. Okay? 1 bit transmitted, they need 1 wire. 8 bit, 8 wire. You know your computer how many bits? How many wire?
Can you repeat that? I didn't hear you.
In the past, computer they're using 32 bit. They get 32 wire. Now, 62 bit. Okay? They get 62 wires. That means in the computer now, you get 62 wires for address and 32 wires for the data. Okay? They're telling you they get it where to transmit by serial. Okay? However, if that serial connect into the computer, into your phone, inside will be a microcontroller. Microcontroller, the same computer, microprocessor. They cannot do anything with serial data. Only thing in computer or microcontroller, they get a device, anything inside, they just working with parallel data, cannot be serial. Okay? So, in your cell phone or the computer, they get a device. When they get a serial, they must be converting to parallel data. You see that? The thing is when they transmit a wire, they don't want to transmit too many wires. They want only one. If you get a only wire, one wire for transmit the data, they must be serial. However, when they go up to the computer, that serial must be converting to parallel data. That device they call a serial data conversion. You will be learned in this course, okay? And after the computer process do anything they need, they will be sending out, okay? However, computer, they sending out the data have to be parallel. Okay, when they get out of the computer, they transmit it. They must be serial. Okay, otherwise they need to melt the wire. Cannot happen. So they get another device. Will be serial to parallel converter. Okay, now you can see the big picture about the data transmitted. Okay, from outside to the computer for processing. When the computer done sending out, they have to get the device we call a D2A converter. Okay, they converting back into analog signal. Both device you will be learned and you will be doing the lab for this course. Okay. Now, this is a table given to you. Okay. You get the number here, decimal. You go 0, 1, 2, 3, up to 15. 16 digits. Okay. And now, binary number. First thing, 4 bit, 0, 0, 0, 0, 0, 1. Okay. And keep going. Then, if you get number 15, they will be 1, 1, 1, 1. Whenever you need, you can look into the table. Okay, you can see this is a decimal equivalent with the binary number. Now, you can see you get a device, they call an encoder. Okay, you know that inside your calculator, they must get this one. This is a human using. Okay, you type in number 159, for example. When they go to the keyboard, they get a device they call an encoder. This device will be change to that number to binary number to the computer. You see that? Come again. I try to repeat. Computer cannot understand decimal number. That's human. Computer only working with the binary number, either 1 or 0. So that's why. If you open the keyboard, you can see you get an IC encoder. Okay? Next one, decoder. Okay, binary code input. That means from the other device go into this device. This IC here, they will be converted into the 7 segment. Like if you typing number 9, then they will be displayed on that one here. Number 9. Okay. Or if you typing, okay, a letter A, then they can display that one. 1, 2. That's A. Okay. So they need a decoder. Okay. To convert it. When you go into the little more into the program detail, you can see one IC. That means one part for decoder. Okay, now binary to decimal conversion. Okay. If you get a number 11011101, okay, that's a binary. You try to convert it to decimal. The answer will be here. We already go through it. And now you need to exercise later. Okay? B you be 100100001, and that is the answer. Okay? Another one. Convert the following decimal number to binary. Decimal to binary. Okay? Like you get number 12. You convert it. Okay? And you get the answer here. And the next one. This number and this number, you have to try. This is giving you the answer here. However, this not important to you. Okay? The thing is we don't have to care about converting. Okay? Same thing. Okay? Converting. Converting following decimal number to binary. And they given you the solution. You need to go to that. Okay? If you get a question, then I can talk to you. Okay? Now, this is the next one. Binary addition. The thing is we don't care about decimal. We don't care about hexadecimal. We care about binary. So the first one, add. Okay, add binary addition. Here. Zero adding to zero. You get 0. Sum of 0 with a carry of 0. No carry. 0 adding 1. Answer will be 1. Sum of 1 which carry 0. 1 adding to 0, you get 1. Sum of 1 with carry 0. Now, 1 adding to 1, okay, equal 0. Sum 0, but carry 1. Now, what that means? Carry 1 means add 1 to the next column. This is just a formula we have to follow. Okay, 0 add 0, you get 0, no carry. 0 add 1, you get 1, no carry. 1 add 0 will be 1, no carry. However, 1 adding 1 answer will be 0. But carry 1. So when we're talking about carry 1, you must understand carry 1 means adding 1 to the next column. You understand? We go from very, very basic. Okay? Okay, add the following binary number. 1, 1, adding 1, 1. 1 adding to 1 equals, correct? That's what the table given to you. However, carry 1. Now, carry 1 means add 1 to the next. So, the next one here, now you need to add in 1. Okay? 1 adding 1 is 0. Carry 1. 0 adding 1, 1. Carry 1 no more. So here. Okay, now 1 and 1, what the decimal number? I can tell you. Just 1. One and 1, that's a binary. You want the decimal. You take 1 times 2 power of 1. Adding the next 1 times power 2 power of 0. 1 times 2. 2 power of 1 means 2. 1 times 2 power of 0. Okay. They will be 1 times 1. And the decimal will be number 3. Okay. That means binary 1, 1 equivalent to number 3. If you don't know, then you can see here. Okay. Number 3 right here. That will be 1 and 1. Number 3. But that is the way calculate the binary to the decimal. Okay, so you can add in this number 100 plus 10. Okay, okay, I can try 100 plus 10. Zero add zero, zero. Zero adding one is one. One down here. You get 110. So now try to see 100. What decimal? 10. What decimal? Okay. If you want the decimal, you have to using that will be 2 power of 2 equal 4. Okay. So that will be number 4. 10. That means 2 power of 1 will be number 2. And the answer will be number 6. Okay. 110. That means number 6. Again, if you're looking into that one, okay. 1, 0 here. That's equivalent to number 6. Okay. Now, next one. Binary subtraction. Okay. Zero minus zero, you get zero. Zero minus one. Okay. Equal one with borrow one. Okay. What that mean for borrow one? Borrow one means subtract one from the next column. 1 minus 0, 1, 1 minus 1, 0. Okay. So, let's see. 1, 1 minus 0, 1. 1, 1, 0, 1. 1 minus 1, 0. 1 minus 0, 1. You get 1, 0. This is the answer here. Okay, let's see. I try number C. 1, 1, 0, 1. Minus 0, 1, 0, 0. One minus 0, 1. 0, 0. 1, 1 minus 1, 0. 1 minus 0, 1. And the last one. 1, 0, 0. Let's see, number C. Okay, I did 1, 0, 0, 1. Number D. Minus 0, 1, 1, 1. 1 minus 1, 0. Okay, 0 minus 1. Okay, let's see. Equal 1. However, 0 minus 1 you get you have to get subtract 1 from next column. That means now you have to subtract 1 in here. Okay, so 0 minus 1. Okay, and you get a 1. However, still subtract 1. Okay, 0 minus 1, you get a 1. 1 minus 1, you get a 0. Still subtract 1. Minus 1 from here. 1 minus 1, 0. 0 minus 0 is 0. Okay? Now, if you try to understand what number 1001 in decimal, for mine, I know. Number 9. 0111. That's number 7. So 9 minus 7, you get number 2. And the answer in binary 0010 equal number 2. Again, if you're confusing, don't know answer, go into here. Okay, 0010 here. That's equivalent number 2. Okay. So we already get through some binary, okay, on the addition or subtraction. Okay, next one. Complement of binary number. Okay, so let's see. The one complement and the second complement of the binary number are important because they permit the representation of negative number. The thing is, computer don't understand the negative number. If you say plus 1, okay. However, minus 1, computer cannot understand. So they have to use it. Either first complement or second complement to deal with a negative number. Okay? So now, the first complement of a binary number is found by changing on 1 to 0 and on 0 to 1. That's very simple. Okay? You get the binary here. That's a binary number. If you want it in first complement, change 1 to 0, change 0 to 1. Keep going. That first complement. Very simple. Okay? And then next one, second complement. Okay? The second complement of a binary number is found by adding 1 to the least significant bit of one complement. Okay? For two complement, one complement plus 1. That means if you want the second complement, you get a one complement first, then you add 1. You get a second complement. Okay, they given you example here. 5 two complement of this number. What you have to do? First, change this number to first complement. Okay, this is the first complement. Then you adding 1. You get the second complement. Add this. Okay. Determine the first complement of a binary number. Okay. Again, for first complement, just change the number from 0 to 1, 1 to 0. Then they in the first complement. In the second complement, first thing you have to do, change number to first complement. Then add 1. They will be second complement. Okay? You will be trying that. Okay, for this one, okay, we not go into detail. However, that's for your knowledge. If you want, you keep reading. Okay? The thing is this program, we try to teach you a little more in computer for calculation, for engineering. Okay? So that's why I adding that for whoever want to know more, then you can read. They said digital such as the computer must be able to handle positive and negative number. So that's why they telling you how they can get that. The side bit, we don't care here. This part just a reading if you get a time. First complement form. Okay. Second complement form. Okay. Let's see. Blood 25. This is the number 25. Okay. The first complement form, a negative number is the one complement of the correct holding positive number. Let's see. This is the number 25. Okay. And using 8 bit, the decimal number, minus 25. Okay. And this will be a minus 25. Okay. You get a plus 25. They can change it to this number for first complement. And for the second complement, same thing. Okay, but we're not going to that anymore. Like express the decimal number 39 as an 8-bit number in the size magnitude one complement and second complement. Okay, if you go into engineer level, and you will be learning detail on that. In this program for technicians, we just given to you. If whoever want to read, you can read it. Okay, now this one, whatever will be need for you, I will be going over. Binary to height conversion. If you get this one number here, binary, and you want to know in height, okay? So they already get the solution. I telling you, very simple. First thing, you get the binary. You want to convert into the height. What you can do, first thing, you count 1, 2, 3, 4. That's first number. 1, 2, 3, 4. Next, 1, 2, 3, 4. Next. Okay? And now you convert it. 110. I know that will be C. 1010. A. 0101. 5. 011. 7. How do I know? Okay, that's it. Here. This is the table. Okay. The table is telling you what equivalent. Now, first thing, you get a number 1100. 1100. One, right here. Binary. You go in here. Height will be C. Okay. The next one, 1010. Here. That will be A. Okay. And the next one, 0101. 0101 here. Number 5. The last one, 0111. Right here. Number 7. Very easy. If you want to know. However, for a while, you get a law. Like now I say 1 and 1 and 1 and 1. I know that height will be F. Okay. Okay, let's see. And if you want to do on the left problem here, okay, take one binary convert to height. I telling you, first thing you count 1, 2, 3, 4. 8 bits for height, 4 bits for height. 1, 2, 3, 4. 1, 1, 1, 1. 0, 0, 1, 1. Okay, 1, 1, 0. So this is, I know, 1, 0, 0, 1, number 9. 1, 1, 1, 0, E. 1, 1, 1, 1. F. 0, 0, 1, 1. 3, 1, 0. Okay, that's a very simple. This table, you have to how to convert it. However, for a while, you get a log. Okay.
On that table where the leftover was 100, what is that one again?
100. Which one? This one,
Yeah.
right?
Yeah, because there's only 3 digits.
Oh, 3 digits. That's okay. Okay. 1, 0, 0. Make sure we count right. 1, 2, 3, 4, 5. Okay. So if you get a 1, 0, 0. Oh, okay. So try to add in height. That means you have to add in 0 here, correct? The thing they must be 4 bit. Okay, very good. So
Okay, so just
the
add a zero.
answer will
Okay.
be not number 4. Have to be number 8. 1, 0, 0, 0. Where the table? Where is my table?
It's down. So 8.
Yeah. Now, that's just a basic. For a while, you don't have to see the table anymore. Okay, let's see.
Right there.
1, 0, 0 here.
And you always go left to right, or do you go right to left?
Left to right.
Okay.
1, 0, 0, 0. Number,
That was my confusion on whether or not it'd be the 100 at the end or 100 at the beginning.
yeah,
So when you're breaking it up in fours,
yeah, they must be 4 digits for hexadecimal. Okay. However, you can understand that must be 4. Okay. BCD. Okay. BCD conversion. Binary code decimal. Okay. This is 0, 1, 2, 3 up to 9. Okay. BCD converted its number to BCD 35. Okay. And you see 35 3 5. Number 3 0, 0, 1, 1. Only thing make sure BCD must be 4 bit, number 5, 0, 1, 0, 1. That's number 5. Okay. 98. Now you can number 9. Number 9 from the table. They will be 1, 0, 0, 1. They must be 4 bit. Okay, number 8. Okay. They will be 1, 0, 0, 1. 0 here. 9, 8. Just for your knowledge, we not using that in the digital circuitry we have to deal with. Okay. And also they can tell them how to add BCD 0, 0, 1, 1, adding to 0, 1, 0, 0. Okay. I given you an example. Okay. So you can see 1 adding 0, 1, 1, 0, 1, 0 adding 1, 1, 0. Normal. Okay. And you can try. Okay. If we get problem, then just bring it up. Record. The thing is the system, sometimes they using different code, they're doing something else. One of that they call gray code. If you want, you can see decimal here, decimal. And the gray code here, equivalent. They must be 4 bit. 1, 2, 3, 4, 5, 6, 7. Okay, binary. And now, how to get gray code? 0, 1 here, 1, 1, 1, 0. We have to follow the table. When they build different machine, they need a different code. They can using either gray code or whatever. Okay? Binary to gray code conversion. If you get a binary here, you want to change the gray code, first thing 1 here, you put a dot. Okay? Then 0. Okay? They adding 1. You get a 1. Then 1. Okay. Adding 1, you get a 1. And keep going. Okay. Then you get a gray code. That's for the different machine. So we don't care about that. Okay. And this will be gray to binary. If you get little gray code here, you want to binary. First thing, 1, put it on here. And 1 adding to 1. You get a 0, no carry. 0 adding to 0, you get a 0. 0 adding 1, you get a 1. 1 adding 1, you get a 0, no carry. Okay? That's a very simple. ASC, nothing to talking about that. That's telling you equivalent for anything in the computer. Try to deal between different number. Okay? And I will be quickly get through this one and we'll be stopping. Okay? First one, they're talking about Boolean algebra. Boolean algebra at the beginning. Later on, they're not using Boolean. The basic we need to know. Later on, they're using control map. That's another way to design the system. Okay? But the basic here, you need to know. Basic on the Boolean, a plus 0 equal a. A plus 1 equal 1. That will be telling you one thing. If you get a 1 adding to 1, adding to 1, you get what? That's what we're talking about, logic, not a math. Inside the computer system, you get only two things, 1 and 0. 1 is the computer that made logic 1 plus 5. Logic 0. Okay. Then 0 means right. So in the computer system, you get only two. Either the logic 1, 5 volt, or logic 0, right, 0 volt. Okay. A plus 1 equals 1. A times 0. A times 1. A. A adding A. A. Okay. A adding A. No, that is, I think, this supposed to be A adding not A. A equal 0, not A equal 1. A equal 1, not A equal 0. Okay. A times A equal A. A times not A. Okay. In here they're using that one. Mean not A. Not equal A. Not the bar over. That means not A0, not A will be 1. Okay. A not not same thing. A not equal A. Now, if A equal 1, so not 1 will be 0. And not again, not 0 equal 1. Okay? And now, A or AB equal, if you put A outside, then adding A, and that will be 1. Adding B. 1 adding B equal 1. Anything adding to 1 have to be 1. So they equal A. That's why, right here. A adding AB. Okay. So let's see. They cannot be the same. I think maybe that is not B. Okay. A orange, not B. So A1. I will take that one. But the thing is, this one we're not using anymore. So we don't care about that. Okay. A or B times A or C. That will be called here. Now, only thing here, you must be memorize this formula. Sum of product. You get X times Y, not X times Y. Okay. Now you break it out. X will be not X. Y will be not Y. And will be converting all. Okay. And product of sum. If you get X plus Y or Y, same thing. Over bar. You bring, you want to take the bar out. So you take it out. X will be not X, Y will be not Y. Only thing, all here will be N. Okay? So on the first one, here, okay? Oh, this one. When you're learning about next one, the OR gate and the AND gate. This is De Morgan theory converting from AND to OR 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 to AND. Okay? Okay, so that next time we're talking about the part, the IC and gate look like. Okay? And we're talking OR gate, inverter, okay, not NAND gate. You see this the IC, okay, NOR gate, okay, exclusive or exclusive draw, okay. Then you will be learning about doing the left, okay. The thing is the theory on digital fundamental. Just given you the basic. Later on, you will learn a different type, like how they converting from decimal, okay, to binary or binary to the decimal, okay, a character, okay. So next week we don't have a Zoom. We will get the Zoom next week on the class in Zoom 240. Okay? The thing is on that
On
day I
Thursday?
have to be in the class. So I cannot do at home.
Okay.
So we will be doing up in Zoom 240. Okay? Around at 4 o'clock. Okay? In the Zoom
Thursday at 4?
40. Next week,
You
one
said
doctor, he got a problem. He cannot show up. So that's why I have to be in the class. So I will be teaching you guys. Keep going on the Zoom 240. And also, I want to show you the circuit board, how to build it, how to do it. how to deal with the C++, write the program, how to test it, okay? So that will be on the next week. Quickly go through this, the logic gate in here, okay? So, any question, anything?
No, no questions.
Okay, so,
Couple of questions, sir.
yeah, yeah.
First of all, where can we find the recording of this lesson?
Oh, you go into the Canvas, take you,
Okay.
click on video.
Ah,
I will be uploaded after meeting today.
all right. And the other question is,
Yeah,
can you also put the PowerPoint on Canvas?
okay.
The
Slides?
handout,
I
it's
know,
on Canvas.
I know what to say. So I will be upload the handout, okay, on Canva or PowerPoint.
Ah, thank you.
You're welcome. Okay. So basically, on this texture, you don't have to stay in the class every day. The thing is, after you get the circuit board, you get the wire, you get the tool to do it, you can build at home. You see that? You can build a circuit at home. When you need to develop the software, you can do it at home, but you have to working in the class so we can help you to fix any problem. After you know how to do what to do, no big deal to me. Only thing is, we given the lab and we want to be done and you get through it. That means you done lab 1, then the lab 2 and 3 keep going. Okay? It's a real work. This program on TechQ try to help you to do the real work in the company. Okay? In the company, what technicians try to do? They get a circuit board not working, and they given to you, and you will be test running the test program wrote by engineer. If it pass, that means the ball working. If it fails, your job will be fixed. Okay? That's a real job. Electronic just telling you basically what is the differential amplifier, what the CE amplifier, or JFET, just a very basic. Okay? So you don't have to do more on left phone if you already done. The key point is on this semester, when you build the circuitry, you run the test. If it fails, not pass, I teach you how to fix it. Okay? Both software and hardware. So, Thursday coming, we'll see you in Zoom 240 at 4 o'clock. Okay?
Okay.
Okay, so have a good weekend, okay?
Thank you,
All
Mr.
right, thank you.
Pham.
Take care.
Okay, bye-bye.